Hi, my name is Franklin MacArthur, and this is hopefully a final screen capture that I'm doing. Anyway, the reason I'm talking here is that I just fixed a special effect that I had accidentally uh, broke by accidentally removing a call to a compute shader to run a Gaussian blur on my luminance texture before adding it back in with additive blending and tone mapping at the end of the scene rendering. But anyway, this is what I originally intended it to look like in terms of picture. There's a few things going on here. So very briefly, Bloom is a very well-known industry standard technique, and just very quickly, going over how I did it. Basically, I'm rendering my scene back to front, and for the shield effect, I have to make sure that everything is rendered in order from the eye, from farthest to nearest, because the input to the shield effect is the background just rendered. But anyway, right here, you could see this animated texture right here. Yeah, the frame rate is dipping a little bit. The GPU is having to work a little bit here. So I'm moving it around my perspective. Okay, you have lens flares and you have light rays right here. So I have an animated point sprite texture right here, and I'm going to describe really quickly the bloom effect. Anyway, for bloom, what I'm doing is I'm rendering into two color outputs. Okay, so when I'm rendering it, first of all, I'm creating the standard output scene, and for the color for the explosion here, and then I'm running a dot product on this color with a specific set of constants for luminance, and if that value is above a certain amount, I will then write the color output to a luminance texture, just a texture that is about 1/4 the size of the screen. For each element of this texture, I'm using a floating point value width for each color component to have as much definition as I can. Um, and then what I do is I run a compute shader on this, a Gaussian blur compute shader about 12 times, and then and you don't have to do it 12 times. You can do it any number of times, whatever looks good, and then add it back into the scene at the very end using high dynamic range lighting and tone mapping. And you can get an effect similar to this. You may even be able to get one a little bit better. Now, as far as the animated point sprite goes, you can create this texture fairly quickly, easily. I came up with this. Well, everything that you see, I wrote from scratch, but this is an effect that turned out rather nicely. Um, and for this, you take the incoming texture coordinate, multiply by 2, subtract 1. Okay, now take the arctangent of that, since that's going to be Cartesian coordinates, arctan y, x, and it just matters that you have -1 on one side, +1 on the other, so Cartesian coordinates, you take the arctangent of that. Okay, now you take, now we're going to set that value aside, okay, so now we need to know how many light rays per point sprite, okay, well, we need to know radians per light ray. Okay, so you take 2 pi, divide that by the number of light rays. Okay, now we have radians per light ray, and um, from there we take that arctangent value beforehand, divide the radians that we just figured out into that arctangent. That gets me a quotient and a remainder. We're going to subtract the quotient. Okay, so now, after we subtract the quotient, we have a range from 0 to 1, okay, and inside that range, that's where the light ray is going to appear there. So all the way around, we broke it up, those however many light rays, into a range that goes 0, 1, 0, 1, 0, 1, all the way around. Okay, so now I need to convert that 0, 1 to 0, 1, 0 per light ray. Okay, so I take I take that 0, 1 value at that point, multiply by 2, subtract 1. Now it goes from -1 to 1. Now take 1 minus that absolute value of -1 to 1. Now I have 1 in the center and 0 to either side. From there, I can take that value and use a power function to flex that value up towards 1 on either side or down away from 1. can do anything you want to that. And from there, I color the red-green components based on intensity, and there are some other factors you can use to do that, but those are the most important parts. Then you can use a noise function. GLSL provides a noise one function that you can use. I actually didn't do that. I used a noise function I read from a game programming book, and it works fairly well. I believe I based this on the timer, and while I'm paused, I move it around, and you can see this. The thing I'm working on right now is this cutoff right here. You can see this is very nice. Where in the bloom effect right here is where you have the light that seems to bleed around the edge. The other effect that I'm not detailing right now, because it is a bit confusing and advanced, I might do this in another video sometime, maybe, is this point sprite. It's not enough to just create the point sprite to do this, but the way I'm writing this um, is I have it so that if the center of the point sprite shows up, the whole point sprite shows up, so that the rays will render in front of the occluding object. And what I'm specifically working on, it might take me a little bit right here, is to make the technique a little bit more advanced so that it doesn't cut off completely as the center is crossed, like right there it's crossed. And anyway, that's it. So putting back in my Gaussian blur, put the effect back in, and I started to think that I had some kind of a multi-sample anti-aliasing problem, and as it turns out, that wasn't it. So when you're programming something, in graphics especially, you have to be very careful. But anyway, this is a labor of love. I really enjoy it, and I'm hoping to keep making this better and keep showing off as much as I can. So here's the rest of this. You can enjoy.